Okay, so one of the things that we need to do, or at least I need to do as a math teacher, is I'm supposed to talk about the Common Core. So there is a Common Core. And so the topic today is N for number sense. Rational numbers are NRN. Number sense, rational numbers. And it's basically understanding the real number system. Okay, that's the Common Core piece that we need to learn today. And we've been talking a little bit about what these numbers are, okay? So we made a little Venn diagram, and I put the little symbols in. We got the real numbers, which we know are all the numbers. Any possible number you can think of, whether it's a decimal or pi or a square root, any number you can think of is a real number. So within the real numbers, so there's two categories. We've looked at this before. The rational numbers, which can be any fraction. So I'm just going to write here fraction, right? Any number that can be a fraction is a rational number, right? And then within that are the integers, and the integers are positive, negative, and I'll give you some. We'll go like -1, 2, and maybe -8. Those are integers, right? This is examples of integers. Positive, negative, whole numbers, but not fractions. Whole numbers are just the positive ones, but 0 is included. So 0, 1, 2, so forth and so on. And we learned that the natural numbers, those are the numbers that are just the counting numbers, just the counting. It does not include 0, so those are just like the 1, 2, 3, okay? Now you might say, what's the big deal, Mr. Davies? Why do we need to learn this? Well, it's on we just saw it. We just saw an example. This stuff's on the test, right? So if it's on the test, I want to teach it so that you won't miss it, right? Pretty important, all right? So the irrational numbers, those are the weird ones. Those are numbers like pi is a irrational number, okay? Square root numbers, square root of 5, that's an irrational. And then there's another number we're going to learn, not till the end of the year. There's a number called E. Yeah, Euler's number. And we don't need to know what E is yet, but we're going to learn it, okay? We will learn about E later, okay? It has to do with continuous growth and how things grow in nature. Okay, what's their rate? It's this weird number called E. Okay, so let's look at the chart. Okay, so class 5. Okay, so first of all, -1/2. Is that a real number? Yes or no? Is -1/2? Yeah, that's a real number. Yes. Is it a rational number? It can be a fraction, right? That can be a fraction. I say yes. Is it an integer? Is -1/2 an integer? No. Is it a whole number? No. Is it a natural number? No. Everybody okay with that? Thumbs up? Thumbs up. Everybody good on that? Okay. How about 0? Is 0 a real number? Every number is going to be a real number, right? Every number is going to be a real number. Is 0 a rational number? It can be a fraction. I mean, 0 over 1 is a fraction, right? So I'd say yes. Is it an integer? Yes. Is it a whole number? Yes. Is it a natural number? No. No. 0.25. Is that a real number? Of course, Mr. Davies, every number's a real number, right? Is it a rational number? Yeah, because it can be a fraction, like 1/4, right? Is it an integer? It's a fraction. No. No, it can't be. No way. Can it be a whole number? No, it's a fraction. No, no way. Is it a natural number? No, no way. 0.3 repeating. Is that a real number? Yes, Mr. Davies, every number is a real number, right? Is it a rational number? Can it be a fraction? Yep. Sure, the same thing as 1/3, right? So that's a yes. Is it an integer? Nah, no way. Is it a whole number? Nah, no way. Is it a natural number? No. Square root of 3. Is that a real number? Megan say, of course, Mr. Davies, every number is a real number, right? Yes, indeed. Is it a rational number? Can't be a fraction, can it? No. Is it an integer? No. Is it a whole number? No. Is it a natural number? No. Now, on your quiz, which is a long ways from now, on your quiz, I'm going to ask specifically. So if I were to take a look at this, I would say that this is specifically a rational number. Specific, okay? That is specifically a whole number. Does that make sense? This is specifically a rational number. This is specifically a rational numbers. And this is specifically an irrational number. Because you could just say they're all real numbers, right? Mr. Davis, I'm right because they're all real numbers. But I'm going to say specifically which one is it, okay? Now what about this? Are there such things, are there numbers that are not real? What do you think?
Would that be like variables, like A or X?
You're on, no, because those would be just variables. Because variables can represent any number, right? I don't know if you guys have ever heard of this. Anybody? What do you think?
What about infinity?
Oh, that's really good. You know what? I haven't heard anybody say infinity for a long time. Let's put that down. Yes. Infinity or negative infinity, because infinity is not a number. It's just an idea. You can't count to it. You cannot count to infinity, right? You can't get there. It's a sideways 8 for infinity. What do we write infinity up there?
No, there's negative infinity.
There is. Yeah. Well, yeah, think about a number line though, right? And in calculus, on a number line you got infinity and negative infinity, right? And then there's one other. I don't know if you guys have ever heard of this number. I. Anybody ever heard of I? Okay, what I happens to be is the square root of negative 1, which is impossible, okay? That's called an imaginary number, okay? These are infinity, and these are called imaginary numbers. Okay, all right, so let's look at page 10, 2 through 4, 23, and 24, and I'm going to help you with today's homework a little bit, so I model what I want, all right? Any questions? Okay, I'm going to stop the camera. Come on. Come on. Turn off.